Hi, it's time again to do a new video for the for the BACnet mesh solution we have been developing lately. It actually demonstrates how Conectric wireless mesh wireless sensors using mesh networking can communicate with a Dingo, and the Dingo actually maps them, all of them, to virtual BACnet objects. Let's first study the hardware we are using. We are using the hardware, same hardware as in last session. We have a Dingo box here with a Raspberry Pi COM1 module. New boxes are all provided with Raspberry Pi COM3 module, but the one module is fine for this purpose. We have here the Conectric USB stick for communicating with the sensors. And down here we have the sensors. We have a motion sensor here. We have a window switch sensor that actually gives pulses each time this magnet here that is then fixed to the window moves away and from the sensor. And finally we have a temp humidity sensor here, actually in the same box as the window sensor. So, and what is regarding the hardware solution here, if we take this sensor here and move it aside the Dingo and we make some traffic here, let's see, if I give a pulse here, dunk, we get a signal on a status indication on LED status LED S3. So this is actually the hardware solution. Let's take a look at the software solution, how auto-configuration will now be performed. Here we are logged in as a Conectric user, so we get access to the Conectric user space, where we have two groups: Go-IoT Cloud that has nothing, and the work area here where we have actually defined one connection to a Dingo. That's actually the Dingo we presented just before. So I'm going to, in Dingo Manager, connect to it. And as the auto configuration we are going to demonstrate here is all based on templates, will go very briefly through how the templates are set up and then used for performing the auto configuration. So let's start first here in the peripherals. The tabs we are interested in here is the BACnet tab and the peripherals. The peripheral is a low-level connection to the Conectric sensors, and actually all other types of peripheral like Modbus, etc. Okay, let's go briefly through it. We go into the controller section here, and the controller marked with the green triangle is the active controller. So I expand that one, and then we have the buses we are managing from DINGO-Stack, and one of the buses is the Conectric mesh auto configuration. So let's expand that one, and there we have those yellow templates. For example, if I click this motion one, you see it's marked as template. If it was not a template, it would be gray. So it's a template, and the same for the switch and the temperature humidity sensors. Those are the three sensors we currently have made templates for. When there are more sensors, we will add templates for those. The fourth one, the LED manager, is only intended for the installations on Dingo hardware, where we can use one of the LEDs on top of the box to monitor traffic back and forth from the Conectric USB stick. So it's a blinking LED, green for outgoing packets, red for incoming packets. So that's the templates for the peripherals. Notice here we have actually added one property here called pulse, both for the motion sensor and the switch sensor. We also have pulse, and that's only to enable simple connection to BACnet pulse counter object. So let's then check out the BACnet configuration.
and we go into the main device here again with a green triangle. The Conectric sensors will be presented from the DINGO-Stack as virtual BACnet devices, each of them. The DINGO-Stack supports such so-called virtual devices. You can use one-wire devices, Modbus devices, and so on, and actually present them as virtual BACnet devices on the BACnet network. So we have here a Conectric gateway, and let's see what we have there. Yes, again we have those three templates. So it's a template. You see, it's marked as a template, and the same here. If we take the motion sensor, as we did for the peripherals, we have an analog object for the battery voltage, and we have a binary input for the motion itself. And notice both of those are co-enabled. That is to say, change of values can be subscribed from BACnet clients, plus internally for trend logging, that I will come very soon to. So the third object here is a pulse counter, or sorry, it's the name is actually correct, pulse converter in BACnet. And those are then the three main objects, and of course it has a device object here describing the device, the motion sensor. And down here we have templated three trend log objects. One for the motion that actually just trend logs the curves, the change of values. One for the battery that is regular, that is to say it trend logs the battery voltage every midnight, once a day only. So, and then we have the pulse trend log here, and that logs from this pulse counter, and it works that way. It logs every 15 minutes the pulses collected inside the last 15 minutes. Then it resets the pulse counter to 0 and starts collecting pulse counts for the next quarter, and so on and so on. So we trend log actually the incoming pulses each 15 minutes. So those are the templates. It's similar for the temperature, humidity, and switch. I'm really not going into that in any details. For example, temperature, humidity here. We have temperature, humidity, battery. So it's very simple and trend logs of everything. So this is as it is now. There are no other devices here, only the templates. So actually there is no active virtual devices currently for those sensors. So what we do now is actually we are going to show how a device will auto-configure. Just to note it, before we started, we removed the batteries from all the sensors. All the Conectric sensors are battery driven, and we have removed the batteries from all of them. So what I'm going to do now is to put in a battery for the motion, temperature motion sensor, and we'll see what happens. So the battery is in. So it has probably sent some data to the DINGO-Stack. Let's see. We go to the peripherals here, and let's refresh the Conectric mesh bus, so to say. Refresh, and we have a temperature humidity sensor here. The gray one, it's not a tablet, it's an active peripheral for this temperature sensor, ending with MAC address 1851 hex. So let's see what happens then in the BACnet part. In the BACnet part, we also refresh that one. Refresh. Oh yeah, we have a red one, and the red one is actually a temperature humidity sensor. So everything is here, but where are the trend logs? Well, the trend logs are actually by convenience put into the main device. So I have to refresh the main device too. And then we see pretty soon that we have 1, 2, 3 trend logs. For trend log humidity sensor 1851, battery, humidity, and temperature. So everything is in here. what we will now do, I will put the battery to the rest of the sensors, the switch and the motion sensor. And let's see what we get here. It's enough to show it here in the BACnet part. The same thing has happened in peripheral part, so there's no need to go there. We refresh the main device just to see the trend logs, if they have. We have more trend logs now. Seems to be. Takes a little time to reload. We had before those temperatures, 3 trend logs for temperature. Now we have switch, battery, and pulse for the switch, and the same for the motion. And up here in the virtual devices for Conectric, yep, we have 2 more devices, definitely. So all auto-configured, and this one is the motion sensor here. You can now, if you want, either fine-tune the generic devices or have them as is. You can also, before you turn the sensors on, modify the templates or make different templates or whatever to get the exact functionality, BACnet functionality you want. So that's up to you. But we provide default templates that you can use right away also. So this actually explains how we auto-configure, just to auto-configure from sensor to BACnet. As a final step in this, let's take a look at what we have in whatever BACnet client. Here is the Jappy. It's a simple BACnet browser, and let's activate it. Okay, it finds all those devices on a network. It finds the 555, that's our device. It finds the temp humidity sensor, it finds the switch, and it finds the motion sensor. There we have the battery, we have the motion, and we have the pulse converter. So let's subscribe to the course. And then there are 0 pulses, and then let's move the sensor around. You see the pulse count is ever increasing, so it's counting pulses from the motion sensor. Let's view some of the trend logs here, or one or more trend logs. Let's take, for example, the trend log switch and say show trend log. What we have there? Oh yeah, we have 2 status records at the startup, and then we have false true, false true, false true. And as this is logged as course, it generates an irregular time-based time series. So that actually shows in quick steps how the auto configuration works, and next we will show you how the auto configuration from BACnet to the cloud works. In this case, for uploading data to the cloud server, we use a BACnet Stack app that is actually running inside the BACnet Stack, and can be found here in the modules page. There we have IBM Watson to BACnet gateway, but we also have the trend log pusher that we use for this purpose. And it's a utility that's on regular basis searches for trend logs on a network or the local device, actually controlled by a parameter down here. From local device we will select here, but you can also take the whole network or select the devices, and uploads to an FTP server located in our Go-IoT cloud server cluster, and logs into it and upload an XML file there. And this happens every 15 minutes, that is at hour change and 15 minutes over, 30 minutes and 45 minutes over. And we are also offsetting that by 5 minutes, 300 seconds. That's because we are trend logging on 15 minutes interval, and we want to send the file just after the trend logging has securely happened. So this app responsible for uploading trend log data to the cloud, and we simply start it here, and we take a coffee break and see what happens after 15 minutes or half an hour or something, to see if we see some data in the cloud. Let's take a coffee break. So half an hour or 45 minutes are past. I'm not sure, it was a long coffee break. Before we take a look at what has been auto-configured in the cloud, I want to mention or show you what has happened here in the app for TrendLog Pusher. By the way, this is the user interface that is automatically generated by the parameter setup for the app. So whenever we do an app in the DINGO-Stack, the user interface itself is auto-generated with tooltips and everything. So that's quite easy. Let's now press this button again, loggers here, that was actually empty before. Now we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9 trend logs. Okay, no further explanation of that. We have a parameter up here, it's the parent ID. This parent ID can be used by whatever cloud server we are using to somehow indicate where in the cloud configuration things should happen. And it's 429, notice that, it's 429. And that 429 is actually the ID of this guy here, 429. So let's now just refresh and see what has happened here. If I say refresh, you see we have got a new gateway, and there we have those 3 items, and what we are interested in is the meters part here. And you see there we have 1, 2, 3, 4, 5, 6, 7, 8, 9 devices registered. It's a motion sensor with battery, motion and pulse, switch with battery, pulse and switch, and temp humidity, battery humidity, temperature. So this has been auto-configured by the first file sent over. So bear with me and remember that those are actually the same items as we have seen in the Dingo itself. So let's see if we have some data. Let's go, for example, here to the humidity sensor, and there has been created a time series for it of number of the ID of the time series is 101,005. And let's see if we have some data there. Enough, isn't it? Yeah. And we have data of the humidity registered irregularly, because we are logging coves, not polled values. So we have data here. Let's take another example. For example, the pulses from the switch. Here it is, and that one has a time series ID of 1003. It is unitless, of course, because pulses doesn't have unit really. It's just 0, 1, true, false. And let's edit it, and let's see what we get there. First of all, it's a regular time series because we are polling on every 50 minutes. So first here is everything is null. So if it's 00, it's from the beginning of the day, 11th probably or 10th, and we scroll simply down to see, oh yeah, in the bottom we have the first values from 1815 and 1830 today and 1845, and those are the pulses we put in. So this actually demonstrates how actually BACnet has been auto-configured to the cloud. From here you can either use whatever cloud system we have in Go-IoT Cloud to view the data, or you can simply access the data by BACnet web services from whatever software you have there. Wherever that software is located doesn't matter, and it even doesn't matter if you are retrieving the data here from those time series here, or from let's connect to it again, from the trend logs, etc. down here. It doesn't matter if you are taking it from here on site in the building or from the cloud. The interface is exactly the same, and you can mix and match as you want. Okay, let's explain this a little bit better with regarding the BACnet web service, because it's so important. Here we have some schematics explaining this. On the left side here, we actually have the cloud server with the Informix time series database in the middle, and around that we have created a software adoption layer and access control layer, and then wrap the whole thing in a DINGO-Stack. Why DINGO-Stack? Yes, because we want to access the data here in the Informix database as with the BACnet web service interface, just like we do with any buildings here that are shown here on the right side. Those are actually presenting 3 different buildings here installed with DINGO-Stack. So using BACnet web services in the cloud or building or wherever you are located, you can actually access the data on a secure manner with encryption and authentication. You can access the data with BACnet web services. Back and forth, you can both write data, control data like setting actuators, or listen to subscribed coves or poll data or whatever. You can do it from Node-RED, systems like Node-RED, DigiLogs, Grafana, energy management systems, just name it. The same for those systems. If you want to read data directly from a building, well, then you go this way actually to the buildings, and exactly the same way you retrieve data and send control data. So you probably don't send very much control data to the cloud server, but this way you can do it. But the interface, the importance here is that the interface is this BACnet web services on BACnet web services here, and it's also on this side here. It's BACnet web services. So that's the importance of it, and you can read from whatever building you want. Yeah, that's it. More to say. Grafana, for example, it's a free graphing tool for energy management or whatever you are doing. There we have actually created, to make this simple, we have created BACnet web services Grafana data source. So it's very easy to adapt Grafana to whatever BACnet web services data we have on this side, Node-RED, we have also deployed some demo classes that makes it very easy to start using Node-RED. And this is more or less straightforward. Many of our customers are doing BACnet web services, retrieving data via BACnet web services to their software, so this is no big deal, so to say. Okay, that's it for now. Thank you.